Hello, Luke here. This is the next video in the series on building a sound detector. And we've trained our model, our machine learning model, and now we're kind of moving into the post-processing stage. As we get there, kind of the transition is we've got to figure out how to actually use this model. So in the last video, I kind of briefly went over how to train it. But now I want to just look at well, what does that actually mean? How do we make use of this? So first thing you're going to do is download the model. So wherever you build it, you need to grab that, save it as a folder. And so I brought it in. I called it hethsongs.model, and I copied it into the folder I'm working from. And so now it exists here. And I imported TensorFlow so that I can make use of it. And I'm going to just load in the model with this little string of code. So song model, and then TensorFlow. The function here is tensorflow.keras.models.loadModel. So that's kind of just a copy paste, right? Like there's nothing fancy going on there. I put in the name of the file or the folder, and it's going to load that in. Below that, what I've got is the reshape that I need to do, because I didn't want to memorize that. That's just from whatever shape of image you used in training your model, you have to use that exact same shape to use the model. Otherwise it won't even work, right? And that makes sense. It's been trained on specific images, thousands of images that are a precise shape, and now we got to make sure we put whatever we feed into this has to be that shape. So I've copy pasted that as well, just so it's here. It's this number of columns. Okay, good. And now what I'm going to do is I'm just going to build out a little function of how to make use of this model from my spectrogram. So this is the same code as earlier in the tutorial, so you can go back and review if you need to. But I'm just loading in a spectrogram from a wave file, and I have the ability to display spectrograms in a familiar way for me, and really that's it. So just gonna split this, make sure I run that and load it in, and I'm gonna just build out a function here. Let's call it song predict, and I'm going to have to bring in my spectrogram, and I want to have a start column, but let's call it a time, right? We're going to actually bring a time on our spectrogram into this, similar to what we did before over here with start. So this is the time where it's going to start, and we want to bring in a model, a machine learning model. So those are the three things we need. And first off, I'm going to grab the snippet of the spectrogram and call that array. So I want to slice my spectrogram. I'm going to get all the rows. So that's what this part is, this colon. And then in terms of columns, I want to go from my time, turned into an integer, times my conversion ratio that I used before. And so maybe what I'll do is bring in that conversion ratio as a parameter or an argument in my function. I could make it a global variable and use it that way too. You can think about what makes sense for you. I'm aware that this function I want to be universal and versatile, and so there might be scenarios where I'm bringing in different models that use different shapes, different conversions, and so maybe it's nice to have this conversion ratio be a parameter that can change and still make this a useful function. So you got to think about it as you build yours. And it's going to go from that spot to, just to make our code more clear, we're going to go start call equals int time times CR, right? And now it's obvious what's going on here. And I'm going to add 69 columns because that's the width of these images. And you can see that down here in the shape. So that's working. And then I'm going to reshape it. And this little reshape is just, you know, it's kind of this weird abstract thing that kind of nests the array into another dimension. Doesn't really matter. It's just kind of like, I'm not even gonna wrap my head around this. I just know that this is the shape that the array had to be in for, you know, what I was using in the building the model. And okay, so that's the shape it's got to be. So now what I want to do is normalize it. So I'm going to still call it song array, but I'm going to just do a quick normalization function between 0 and 1. And this comes up in data lots where you want to normalize things for various reasons, maybe for regression or a machine learning model or whatever. So you want to be able to do that, and you're going to subtract the min from the array, and you're going to divide by the max minus the min. I think I brought that up in one of the other videos as well. Yeah, it's worth knowing how to do this. Maybe we'll print in there and just see what we get. So invalid syntax. Oh, I did equals instead of minus. There we go. So let's run this, and we'll just see what we get. Let's run it from 200 seconds, and we'll bring in our model, and we'll bring in our conversion ratio. And song array didn't work. Oh, because I called it array and then I called it song array. Okay. Okay, sure enough, it is reshaping. If we printed it out, so we're kind of halfway there, that's good. What I want to do is make a prediction with my machine learning model. So I'm going to call it prediction, and I'm going to go model.predict. So that's the function that we used from TensorFlow to use our model and predict with it. And I'm going to bring in song array as a list, and that's just kind of the format that it comes in. And I'm going to tell it to be quiet. Verbose equals 0 or false. It just means don't print to my console every time you make a prediction. And that's because I know that looking ahead, I know I'm going to be making a ton of predictions, and I don't want it just printing like crazy. So I'm going to turn it off, and then I'm going to return whatever that prediction is. And the prediction it makes is in a nested array. So I'm actually going to just access that. It's nested twice within a list. You know, that's just, sometimes you just gotta know these things. If I just did prediction, it would send me a nested array with my prediction number in it, and that, you know, I'll even show you what that looks like. Let's say we're gonna now use this, and we're gonna make a prediction, and then we're gonna print that prediction. And let's do that. It's given us a warning. I'm not going to worry about that right now. The point is we got this prediction right here, and you can see it's in a nested array. So I would rather do this and just grab that number. Now I've got just the number. And I didn't get the warning the second time. So I don't know. Maybe that warning was important. Maybe it wasn't. I'm not going to worry about it right now. So we're getting this prediction. It's almost 0. So what we're hearing, if we want to actually get the meaningful answer, we're hearing our model tell us this is not a hermit thrush song, wherever this is in here. And as you remember from earlier, we can actually display that moment in time. We've got this function that brings in a start time, and it brings in a duration. So let's say 1.5 seconds, and it brings in that. And now we can actually display this. And so you can see here, yeah, that isn't, maybe that's the tail end of a hermit thrush song, but it's definitely not starting at the beginning of it. So we're getting a correct answer. And I'm going to switch this to 202.4 because I think I remember that's where a song was. Oh, maybe it was 204.2. There it is. 302.4 was what I was trying to remember. And this is actually where a song is on the spectrogram. You can see the song here. And now you can actually see the prediction. And it is very confident that this is a song. That's good. If we move that prediction, let's say, I don't know, let's say 0.6 seconds. So that moves it over to 303. And I'll do that here also with the prediction. It goes over to there, and now we get almost 0. So it's again very confident that this is not a hermit thrush song. So far things are looking pretty good. I'm going to stop there, and in the next video what we'll do is we'll sweep through this spectrogram, making all these predictions and graph that and kind of look at how to interpret that kind of throughout the whole string of moments. Kind of when is there a song, when isn't there, and we'll kind of see that graph go from 0 to 1 as it becomes confident and then doesn't. So that's where we're heading in the next video.